this is a Unit 5 review key video. Some of these questions are from the last unit, but they're also going to be included on this next test. So it's very important that we go over them again, just in case you didn't know them from the first time that we took the test. Hopefully this will help. All right, so the first question, use synthetic division to determine the quotient of our problem here. So our divisor is x minus 1, so we're going to take x minus 1, set it equal to 0, and solve for x. So that's the number that's going to be in our little box. Then we take the coefficients of our problem here. We have 1, negative 8, negative 3, and positive 10. And now we can do our synthetic division. We drop the first number, which is a 1, and then multiply that 1 by the 1½ box, which gives us 1. Negative 8 plus 1 is negative 7. 1 times negative 7 is negative 7. Negative 3 minus 7 is negative 10. 1 times negative 10 is negative 10. And 10 minus 10 is 0. We started off with x to the third, but we divided by x, which means we're going to have 1 less x in our answer, which gives us x squared minus 7x minus 10. And there's your answer. Okay, for number 2 and 3, we've done these problems before, but maybe not with polynomials. On the last test, it was done with a quadratic. That's okay, though. It's the same format or method that we're going to use to solve it. So we're given 3 points of our graph. We're given this one, right here, and right here. So the first one is x equals negative 1. Second one, x equals I have no idea. And third, x equals 4. Okay, so we're going to use these two values that we do know and divide our problem here by those two values to find out our third value. Okay, so we're going to have, I'm going to start with negative 1 first in my little box. So I have the coefficients of 6, negative 28, positive 6, and positive 40. I drop the first number, which is 6, times negative 1 is negative 6. Negative 28 minus 6 is negative 34. Times negative 1 is positive 34. 6 plus 34 is 40. Times negative 1 is negative 40, which gives you 0. Okay. Now, that's a quadratic I got from our cubic function. But what I'm going to do now is divide this again using the 4 value from our graph and do synthetic division again. So again, we drop the first number, which is a 6. 4 times 6 is 24. Negative 34 plus 24 is going to be negative 10. 4 times negative 10 is negative 40, and that gives you 0. So now we have our factors, which is what we're asked to do in this problem. It says determine the factors. Okay, so we have x plus 1 from the first point. We know the second factor from the x equals I don't know is 6x minus 10. And the third factor is x minus 4. Notice the factors of the points we did know now have different signs because they are now factors and not solutions. Okay, again, same idea. Given a polynomial, we're given 3 points, there, there, and there. So the first one is x equals negative 3. The second one is x I have no idea. And the third one is x equals 1. Okay. So I'm going to do the same thing. I'll start from left to right. It doesn't really make a difference if you do the 1 or the negative 3 first. I'm just going to do negative 3 because it's on the left. My coefficients are negative 12, negative 38, positive 8, and 42. Drop the first number is negative 12. And negative 3 times negative 12 is going to be positive 36. Negative 38 plus 36 is going to be negative 2. Negative 3 times negative 2 is going to be positive 6. I'll get it. 8 plus 6 is going to be 14. And negative 3 times 14 is negative 42, which gives me 0. So now with my values that I just got, I'm going to do the synthetic division again, but this time with 1. Drop the first number, gives me negative 12. Times positive 1 is negative 12. Negative 2 plus negative 12 is negative 14. Times 1 is going to be negative 14, which gives me 0. So now my values, my factors, are going to be x plus 3, negative 12x minus 14, and x minus 1. Again, notice the values that I do know, the negative 3 and the 1, change signs when they become factors again. Okay, so this is my answer. Okay, now you could have factored from this point here, but there's no need to when you can do synthetic division again. All right. Some rational equations. Sweet. Okay, so first step we need is we need to find the domain restrictions. Now these have already been factored as far as the denominators go. So we just need to find out what our denominators are and find out what the domain restrictions are. So we have p minus 2 equals 0. We have p plus 2, p plus 2 equals 0. And p minus 3 equals 0. So if we solve all these, p is not allowed to equal 2, negative 2, or 3. So those are our domain restrictions. Again, those are the values that would cause the denominators of our fractions to be 0, and thus the whole fraction would be undefined, which we can't have. Okay, now we're going to solve these. So the first step is finding out what's missing. The first fraction has denominators of p minus 2 and p plus 3. It is missing a p minus 3. All right, the second fraction has the denominators of p minus 3 and p minus 2. It is missing p plus 2. So now that we've multiplied by what's missing, we can get rid of our denominator entirely. We have to multiply along the top with our numerators. So p minus 3 times p minus 3 is going to be p squared minus 3p minus 3p plus 9 equals p plus 2 times p plus 2 is going to be p squared plus 2p plus 2p plus 4. Now what we're going to do is we're going to combine all of our like terms. Now, this might look like it's going to be a quadratic because there's a p squared, but when you subtract the p squared from right to left, it's going to cancel that out, which means we're going to have a linear function, or linear equation. Okay, so now what that means is I'm going to take the two p's on the right-hand side, I'm going to subtract 4p total, that gets rid of those, and bring it over to the left, and I'm going to subtract 9 and bring it to the right. So, negative 3 minus 3 is negative 6, minus 4 is negative 10p, equals 4 minus 9 is going to be negative 5. Divide both sides by negative 10, and p will equal 1/2. Now, 1/2 is not 2, negative 2, or positive 3, so that works as an answer. Had it been 2, negative 2, or positive 3, it would have been no good as an answer because it was restricted by the domain. Question 5. So again, we have to find the domain restrictions. Unlike the last problem where the denominators were already factored for us, these are not, so we have to factor them. So we've got to figure out what two numbers would multiply to negative 15 and add up to be positive 2. Those would be positive 5 and negative 3. On the other side, we have a difference of two squares, x squared minus 25, which gives us x plus 5 and x minus 5. So with that being said, we can go in our domain restrictions. We have x plus 5 equals 0, x minus 3 equals 0, and x minus 5 equals 0. Those are the three different factors we have in our denominator. So if we solve them all, we'll get x cannot equal negative 5, positive 3, and positive 5. All right. Now that we have our domain restrictions done, we can look at our equations. So, in the first fraction, we have our denominator of x plus 5 and x minus 3. It is missing an x minus 5. The second fraction, we have x plus 5 and x minus 5. It is missing an x minus 3. Now that we've multiplied to the tops what was missing from the bottoms, we can get rid of the bottoms. Okay, and we just multiplied out. We have 3x minus 15 equals 2x minus 6. If we solve this, we subtract 2x from both sides. We add 15 to both sides. Gives me x equals positive 9. Now that is neither negative 5, positive 3, or positive 5, which are our domain restrictions, so though it's okay as an answer. page. Okay, so number 6, our domain restrictions. These are fractions, the n and the 17. It's just that they have 1 as their denominator. So that doesn't factor into our domain restrictions. The only restriction we have is n equals 0, which means n cannot equal 0. So now we're looking at what is missing for the 3 denominators. Well, the first denominator is n over 1, so 1 is the denominator. It is missing an n term. Second fraction has n in the denominator, which is not missing anything because it is the denominator. And lastly, we have 17 over 1, which is missing n in this denominator. So if we multiply the tops and get rid of the bottoms, we'll get n squared plus 16 equals 17n. Okay, so now this is going to be a quadratic. So I want to bring the 17n to the left by subtracting. Which gives me n squared minus 17n plus 16 equals 0. Okay, so now what I have to do is I have to factor this. To find 2 numbers that multiply to be 16 and add up to be negative 17. Well, it seems kind of complicated, but it's really just 16 and 1. Okay, but they both have to be negative. So if I solve these, n is going to equal positive 16 and positive 1. And neither of those is n, neither of those is 0. Excuse me, so those are okay. Number 7. Again, to find the domain restrictions, we have to factor the denominators first, much like one of the problems above. C squared minus 4 is a difference of 2 squares. C plus 2, C minus 2. Same thing over here. So that means our domain restrictions are going to be based on C plus 2 and C minus 2, which means C cannot equal 2 or negative 2. Okay, so now we're looking at what's missing. Well, the first fraction has both C plus 2 and C minus 2. The second fraction is missing the C minus 2. So let's put that in there. And the third fraction has both C plus 2 and C minus 2. Since we've multiplied by what's missing, we can get rid of the denominators altogether. And we have on the top, we have 1 plus 1 times C minus 2 is just going to be C minus 2 equals 3. I'm going to subtract 1 and add 2 to the right. So C will equal, that's 3 minus 1, which is 2, plus 2, which is 4. Since that's neither 2 nor negative 2, that answer works. Okay. All right. We describe the transformations. There are 2 transformations in this graph. Okay. There is a vertical shift up 8. There's a horizontal shift to the right 5. That's it. Oh. Sorry about that. Hit a button. Number 9. There's actually 3. There's a vertical shift. Sorry about that. Are you kidding me? Sorry about that, ladies and gentlemen. Some technical difficulties. All right, as I was saying, there's a vertical shift. And it goes down by 4. There's a horizontal shift. That goes left by 7. There's a vertical stretch. Of 2. Okay. So, number 10, we're going to figure out what the transformations are going to do to this graph and find out this information. Missed a colon. All right, for the x-intercept, we're going to take the numerators. In this case, though, the numerator has to be 1 minus 1, and you're going to multiply that second one by the denominator of the first fraction. Okay. And you're going to set it equal to 0. Okay, so let's zoom in here to make it easier to work with. So we have 1 minus x. On that negative sign is going to be distributed to both terms inside, so it's going to be minus 2 equals 0. Okay, so I'm going to bring the 1 and the negative 2 over. So I have negative x equals, it's positive 2 minus 1 is 1. So x will equal negative 1. If we write that as a point, it's going to be negative 1 comma 0. So going over here, I'll put my point right there. The y-intercept, I'm going to take the whole fraction, put 0 in for x. So I have 1/2 minus 1, which will equal negative 1/2. So my point is going to be 0 comma negative 1/2. My vertical asymptote is going to be the denominator, setting that equal to 0 and solving, so it's going to be x equals negative 2. You have to put in the asymptote in your graph for when you do these problems. Those dashed lines. Your horizontal asymptote is located at the end, so y is equal to negative 1. So your graph will look like this. There you go. Now for the domain and range. The domain is what x values exist in the graph. Going left to right, we start at negative infinity. As we move to the right, we hit our vertical asymptote at negative 2, which it has to jump over and start up on the other side until it goes to positive infinity. For the range, we're looking at what y values exist for the graph. It starts at the bottom at negative infinity, goes up till it hits the horizontal asymptote at negative 1. Jumps over it, and then continues on towards positive infinity. Same idea in this problem. So for your x-intercept, we have 1 plus 2 times the denominator x minus 3. Set that equal to 0. So we have 1 plus 2x minus 6 equals 0. I'm going to add 6 and subtract 1, which gives me 5. And then divide both sides by 2. So that as a point will be 5 over 2, comma 0. 5 over 2 is going to be 2.5. So at 2.5 on the x-axis, it's right there, put a point. The y-intercept, we have 1 over 0 minus 3 plus 2. So negative 1/3 plus 2 is 5 over 3. Write that down as a point, 0 comma 5/3. If you need to find the decimal equivalent of 5/3, it's 1.6666 repeating. So it's a little over 1/2. So we guesstimate about there. Our vertical asymptote, take our denominator x minus 3 and set it equal to 0. So x equals 3. Putting in our dashed lines. Horizontal asymptote is that plus 2 at the end, y equals 2. All right, and then we can graph our equation. So we have this. Wait. Oh, sorry. I put the wrong dot for 1.66. So, wait, that looks funny. Try that again. 1.66 is about there. That seems better. All right, and then our other part of the graph is up here. Okay, so there's a graph. Sorry about the missing point in the wrong spot. All right, so now we have our graph done. We can look at our domain and range. The domain, again, is the x values that exist in the graph. So we start on the left, which is negative infinity, go towards the right until we hit the vertical asymptote at positive 3, jump over it, and go towards positive infinity. For the range, we're looking at the y values that exist in the graph, starting at negative infinity, goes up to the horizontal asymptote at 2, jumps over the asymptote, continues on towards positive infinity. There you go. Okay, so this says we're doing a rational function. We want to graph by translating the function up by 3 and to the left by 4 on the same grid. So if we take our points that were given in this problem, just take the 2 that are right there. So we're going up by 3 and left by 4. So we go up by 3, 1, 2, 3, and left by 4, 1, 2, 3, 1, 2, 3, 4. There it is. Okay, the other one, same thing. Up by 3, 1, 2, 3, left by 4, 1, 2, 3, 4. So our asymptote's going to be here, in between the 2 points, and then here, in between the 2 points. Your graph will look something like this. Okay, so what's the equation? So this is a horizontal and a vertical shift. So we have g of x is equal to 1 over. Now the horizontal shift goes in the bottom of your fraction. Since it's going left, it's going to go plus 4. And the vertical shift is going to go on the outside. Since it's up 3, it's going to go plus 3. Remember, when it's horizontal, it's the opposite of the sign that you're given. Since we went to the left negative, that means the sign on the 4 should be positive. Okay? If you want to find your x-intercepts, you can do the same thing we did for the other problems. You have 1 plus 3 times x plus 4, which gives you 1 plus 3x plus 12, equals 0. Equals 0. I'm going to subtract 12 and 1, which is going to give me 3x equals negative 13, and divides both sides by 3. So your x-intercept is going to be negative 13 over 3, comma 0 as your point. Your y-intercept, you put 0 in for the x value. You got 1 over 0 plus 4 plus 3. So 1/4 plus 3, I like my things as fractions, is going to be 13 over 3. Oh, sorry, 13 over 4. Misread that. So 0, comma 13 over 4. Your vertical asymptotes, since we moved everything over, your vertical asymptote is going to be at x equals negative 4. Okay, we can do the equation too. From the equation, we have x plus 4 is equal to 0. So the vertical asymptote is going to be x equals negative 4. The horizontal asymptote is that plus 3 in the end, so y equals 3. The domain, starting on the left, negative infinity till the vertical asymptote at negative 4. And negative 4 till positive infinity. The range at the bottom, negative infinity to the horizontal asymptote at 3, and 3 towards positive infinity. All right. Same idea this time, though. We've given the equation. So let's just figure out where it's going to be. We can do the same idea where we just moved it based on the transformations. So we're going to the right by 4 and up by 2. So the right by 4, 1, 2, 3, 4, and then up 1, 2. That's an ugly first point. Right there. The other one is 1, 2, 3, 4, 1, 2. So we can put our asymptotes between the points based on what we're doing. We can just draw these little graphs in here. Okay, so there you go. What are the transformations performed on f of x to create g of x? So we have a vertical shift up by 2. We have a horizontal shift to the right by 4. Oh, you can scratch this part off. You already have the equation right there. All right, x-intercept, we can use the equation just like we have in the past. We have 1 plus 2 times x minus 4. Set it equal to 0. So 1 plus 2x minus 8. I'm going to add 8 and subtract 1, which gives me 7. So I have 2x equals 7. Divide both sides by 2, and x will equal 7 over 2. So I have 7 over 2, comma 0 for my x-intercept. My y-intercept, I put 0 in for the x term, so I have 1 over 0 minus 4 plus 2. So I have negative 1/4 plus 2 gives me 7 over 4. So my y-intercept is 0, comma 7 over 4. My vertical asymptote, so I take the denominator, x minus 4, set it equal to 0. So x will equal positive 4. Horizontal asymptote is the vertical shift, so y is equal to 2. All right, the domain, starting on the left at negative infinity towards my vertical asymptote at positive 4. 4 to the positive infinity. The range is the y values, starting at negative infinity to 2 at the horizontal asymptote, and 2 to positive infinity. Okay. Next, we're going to solve this equation using any method. Solving quadratics is still on the test, so it is still important that you understand how to solve these. This has already been factored for you, so it makes it pretty easy. So we have 4 over 3 x squared equals 0, 2x plus 3 equals 0, and x minus 5 equals 0. Since it's already been factored for us, we can take each factor individually, set it equal to 0, and solve. Okay, for this part, if you were to divide 0 by 4/3, you'd get 0. So you have x squared equals 0. The square root of 0 is 0. Here you're going to subtract 3 and divide by 2. Here you're going to add 5. So these are your 3 answers. Okay. Next, all this stuff needs to be put on one side. So we have 2x to the third plus 3x squared minus 8x minus 12 and set it equal to 0. Okay, these are the problems we had from last unit where we have 4 terms, so we're going to group them and find the greatest common factor. So 2x to the third plus 3x squared, you can only take an x squared out. We're left with 2x plus 3. On the next part, we can take out a negative 4. We're left with a 2x plus 3. Since these two in the parentheses are the same, and we're nowhere on the right track. So we have x squared minus 4 times 2x plus 3. Now normally we'd be done with factoring. The issue is we have x squared minus 4. That's a difference of 2 squares problem. So that means it's going to be x plus 2 and x minus 2, because we can factor that some more. And then the 2x plus 3 stays there. So now we have our 3 factors for this problem. We have x plus 2 equals 0, x minus 2 equals 0, and 2x plus 3 equals 0. So we have three answers. X can equal, so I'll put it down here, -2, +2, and -3/2. Okay. Do have to be careful about those kind of four-termed equations that are cubic functions, or cubic equations rather, because you might be able to factor that 1 again. Okay. Number 16 here. So out of these two terms, there are some things that we can take out that are greatest common factors. We can take a 2 and an x out, which leaves us with x squared minus 16. Okay, again, this is a difference of two squares, so this will be x plus 4 and x minus 4. We still have that 2x out in front. And now these three factors can be set equal to 0. So x is going to equal 0, -4, and +4. All right. Again, we have to get all this stuff on the one side. I'm going to add 3x cubed to the left, minus 27x squared plus 60x. Again, this sets it equal to 0. And just like the last problem, we could take out a greatest common factor. We can take out the same idea. We can take out a 3 and an x, which means we'll be left with x squared minus 9x plus 20. All right, if we factor that quadratic, will be x, and two numbers that multiply to be positive 20 and to be -9 are going to be -5 and -4. We still have that 3x out in front, so now we have three factors to solve. We have 3x equals 0, x minus 5 equals 0, and x minus 4 equals 0. So x can equal 0, 5, and 4. Right, getting closer. We got the work problems. So we have Adam, we have Dan, we have them working together. They're harvesting a field, and it takes them some hours to do. Okay, so Adam can harvest one field in 16 hours. All right, Dan can harvest the same field in 13 hours. How long would it take for them if they were working together? So just like our rational equations from before, we've got to find out what's missing. The 16 is missing the 13 on the x. The 13 is missing the 16 on the x. And the x is missing both 16 and the 13. Since we've multiplied by what's missing on the top, we can get rid of the denominators. So we have 13x plus 16x equals whatever 13 times 16 is, 208. So 13 plus 16 is 29x equals 208. 208 divided by 29 will be 7.17 hours. Number 19. Leah can clean the attic, so we're cleaning, and it's in hours. She can clean one attic in 10 hours. Stefan can clean the same attic in 15 hours. So what if they work together? How long would it take? Now, when I write the initials on the top with the stuff on the sides, that's to help organize your information. I would highly recommend doing this. Otherwise, it becomes a gobbledygook of people don't know what to put down. But if you organize the information like this, it helps out. So what's missing? The first 10 has missing 15 and x. The 15 is missing the 10 and the x. The x is missing the 10 and the 15. So what's missing is up there. We can get rid of the denominators. We have 15x plus 10x equals 150. This gives me 25x when we add it together. And divide both sides by 25, and x will be 6 hours. Okay, Got a couple more of these. Ellie can make 2 hot cocoa bombs in 5 minutes. So we got cocoa in minutes. Cardia can make 4 hot cocoa bombs in 9 minutes. Hold on a second. You know what? We're going to skip 20 because we didn't cover this and it's not going to be on the test. So don't worry about 20. And you can skip 21 as well. Same idea. We're not really going over that on the test. So don't worry about those two. You can skip those. I'm sure you're really upset. All right. Number 22, Chance the Rapper wants to invest his money into stylist business. He charges a one-time setup fee of $30 per order and then $1.50 per stylus. Determine the total cost if 50 styluses are sold, and what is the average cost per stylus. Now, I told you in the notes, these problems a lot of times have 2 questions in the first part. So we're going to find 2 things here, the total cost and the average cost. So there's $1.50 per stylus times 50 styluses plus $30 for just putting in the order for the setup fee. So we have 1.5 times 50 plus 30 gives you a grand total of $105. Okay, then the average cost per stylus, you take the total divided by how many styluses you buy, which is 50. So the average cost per stylus is $2.10. Okay. Part B, write an equation to represent the total cost if X styluses are sold. So we're going to write the equation to codify the first part of our Part A. So we have the total cost of 1.5 times the X number of styluses plus 30. All right. Same idea for the average. So we have the average is equal to the total, which we just wrote down, 1.5 times X plus 30, divided by how many styluses are sold. Okay. Part D. So we can do this using the total cost. If a customer has $150 to buy styluses, how many styluses could they buy? So you have 150 as your total cost. Okay, is 1.5 times X plus 30, and you just solve the equation. So 150 minus 30 is 120, equals 1.5X, divide by both sides by 1.5. And you can buy 80 styluses. Okay, Part E, now we're doing the average. Customer wants the average price to be $1.80. We set that equal to the equation above. Now this is a rational equation. The 1.8 is missing. It has a denominator of 1. It's missing an x. The other side has an x. It doesn't need anything. Now that we've multiplied by what's missing, we can get rid of that denominator altogether. So our equation becomes 1.8x equals 1.5x plus 30. I'm going to subtract 1.5. So 1.8 minus 1.5 is going to give me 0.3 equals 30. I'm going to divide 30 by 0.3. So X would be 100 styluses. Okay. We're almost there. We got one more question. So Miss Marlega is planning her wedding reception at a banquet hall. The hall has a fixed charge of $300, so no matter how many people come, she still owes $300. Plus $35 per person for food. So again, we want 2 things, the total cost and the average cost, if 95 people attend. So it's $35 per person for 95 people, plus $300 for the fee. So 35 times 95 plus 300 gives me $3,625. Now for the average, we're going to take that number divided by 95 people. Which gives me $38.16. That's the average cost. Now, just like before, we're going to write an equation to codify the first equation we wrote. So we have the total cost based on people is $35 times the number of people plus $300 for the fixed fee. The average, same idea, is the total cost, which is 35 times x plus 300, divided by the number of people that come, which is x. And lastly, part D, Ms. Marliga wants the average price per person to be $37.50. How many people should attend the wedding reception? So we're going to take that and set it equal to the average cost. The left side is missing the x term. You can cross that out. So I have 37.5x equals 35x plus 300. Let's zoom that in. I'm going to subtract 35x from both sides. So 37.5 minus 35 is 2.5. X equals 300. Divide by both sides by 2.5. And x will equal 120 people. All right, it's a marathon key. Hopefully you followed along. I'm sorry about that middle part where I hit a button and I screwed everything up, but hopefully got back on track. So study hard, do well in the